Hello, I'm Katrina Carey and I'm shooting a video for all you amateur stargazers out there on how to build a low-cost refracting telescope so you can better see all of those lovely constellations. The first item that you will need is a 1 1/4 inch threaded PVC coupler and plug. You will also need a 5 foot 1 1/2 inch Schedule 40 PVC pipe. You will need a 3 to 1 1/2 inch Schedule 40 pipe reducer. You'll need a 3 inch Schedule 40 PVC to a 4 inch PVC sewer pipe reducer. You will need a 4 inch sewer pipe PVC. You will need a 2 inch Schedule 40 glue and plug, a 4 inch PVC sewer pipe coupler. You'll need a 6 inch PVC screw and plug, a piece of 6 inch clear PVC. You'll need a 150mm by 260 centimeter lens, and then for the smaller lens you will need a 38mm by 5 centimeter lens. You will also need some PVC primer and some PVC glue for later on in the mix. You will also need to probably have a tape measure, and we will be using a tripod to mount this on when we're done instead of building one from scratch. And we're also going to be using a lathe to cut several of these parts so they fit in better with each other. And also remember safety when you're working with the lathe. Wear glasses and be careful with your hands and stuff. And just in general, be safe and have a fun time. You will also need a mill, 4 number 4 screws with 40 threads per inch, and one more 4 inch PVC sewer pipe coupler. During the experiment of studying the night sky, the independent variable will be the telescope and the dependent variable will be the visibility of the stars. In this experiment, you will be measuring the change in visibility of the stars with and without the telescope. The viewing through the telescope should appear better than without it, if all directions were performed properly. Step 1. Drill a 1 inch diameter hole into the 1 1/4 inch PVC plug. Step 2. Place 38mm lens into the threaded coupler and then screw in newly drilled plug. Step 3. Cut off a 12-inch piece of the 1 1/2 inch Schedule 40 PVC pipe. Step 4. Glue threaded coupler to the end of the 1 1/2 inch Schedule 40 PVC pipe. Note, this will be the eyepiece of your telescope. Step 5. Machine the lip out of the inside of the 3 to 1 1/2 inch Schedule 40 pipe reducer. Step 6. Slide 1 1/2 inch Schedule 40 PVC pipe into 3 to 1 1/2 Schedule 40 pipe reducer. This will need to slide easily since it will be your adjustable piece when trying to focus your telescope. If the fit is too tight, use sandpaper to make it more tunable. Step 7. Attach the 3 inch Schedule 40 PVC to 4 inch PVC sewer pipe reducer to the parts from the previous step. Note, this assembly will attach the eyepiece to the new sewer pipe. Step 8. Drill a 4 inch hole into the 6 inch PVC plug so that the 4 inch PVC coupler will fit in correctly to make the output end of your telescope. Step 9. Take the 6 inch PVC plug and cut a slight lip around the 6 inch inside so the 150mm lens can rest there snugly. Step 10. Drill and tap 4 holes through the sides of the 6 inch PVC plug into the piece of the 6 inch clear PVC. This step is to secure the larger lens so it will not be able to move. Note, number 4 screw with 4 threads per inch. Step 11. Glue 4 inch PVC coupler into the hole made in the 6 inch PVC plug. Step 12. Insert the lens into the 6 inch PVC plug and bolt on the 6 inch clear PVC. Note, this assembly attaches the objective lens to the sewer pipe. Step 13. Drill a number 7 drill bit hole into the 2 inch glue-in plug and tap it for the 1/4 20 camera tripod mount. Step 14. Machine the 2-inch glue and plug so it fits snugly against the second 4-inch PVC sewer pipe coupler. Step 15. Glue the 2-inch plug to the side of the 4-inch sewer pipe coupler. Note, this will slide on the telescope and will mount it to the camera tripod. Step 16. Cut a 90-inch piece of the 40-inch PVC sewer pipe. Note, this length makes the total distance between lenses equal to the sum of their focal length with 6 inches of adjustment for the eyepiece. Step 17. Your telescope is now ready to assemble. Step 18. After your telescope is assembled, over the course of several days, take various pictures of the night sky with a camera and then take pictures through the telescope. Step 19. Compare photos taken with and without the telescope. Draw a conclusion on whether the hypothesis is correct. Make a visual of different stars showing the strength of the telescope.